particular sections. So when you use a different program, I was able to stop, pause, and everything like that. This one I can't, so it's just a running string of what we're doing in class. So a little less useful videos, but in the environment that we live in, that's what I'm going to do. When we come back in the classroom, might use that other program where it shortens these a little bit, but that's how you have to function with those videos. Okay, so I did say this in 1-1. Trigonometry in general, my first statement that I wrote there, they're magical little algorithms that allow you to relate side measures and angle measures in a triangle. It's a bridge. It's because triangles are similar is where this comes from. So triangles that have certain angle measures and one side measure, we can use trig to find the other side measures and so on and so forth. Yeah. So before we get into this always intrigues me over the years, and I guess I don't know if teachers really cover this or tell you to remember these things. We're going to be dealing with right triangles, so it might be useful to know your Pythagorean triples. Three numbers that fit very nicely in the Pythagorean theorem. So therefore, if I were to say that a triangle has these sides as measures, 3, 4, 5, you would know right away that that is a right triangle because it fits perfectly in the Pythagorean theorem. As far as relating those sides, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, 5 squared is 25. So this represents side measures of a right triangle. Well, almost everyone knows 3, 4, 5 is a set of sides for a right triangle, but then a lot of people don't have these memorized as much anymore. This was the second most popular. Maybe these two were tied when students back in the day were, really taught in geometry quite well at Lockport. That these were hammered in your head, and hey, if you know these, then you'll be able to function a little bit faster. All right, and then usually this one was the least popular from back in the day. A lot of students didn't remember that. By the way, there's an infinite amount of Pythagorean triples. These are just the 4 most popular beginning ones. Then it goes on forever. I think maybe 9, 40, 41 is one. Yeah, I think it is. And it goes on forever. There's an infinite amount of Pythagorean triples that fit a right triangle. But knowing at least 3 out of these 4 could make your life a little bit faster. All right. So what we're saying is, sure, 8 squared plus 15 squared, if you check this out in your calculator, does equal what 17 squared is equal to. So therefore, 8, 15, 17 could be 3 side measures in a right triangle, or those 3 side measures with 17 being the hypotenuse. That would represent a right triangle. And that's what we're dealing with this first section. Actually, most of the year is right triangle trig. So that's why this is important. Okay, you can see those up in the corner. And then we're going to move on to the main idea. This is like so huge for the rest of the year. The idea that we are doing coordinate trig. Remember the point of coordinates? We coordinatize Earth so that we can find positions on Earth using coordinates, latitude and longitude. People put stuff on a piece of paper and coordinatize it so we can find where things are located compared to others. It's the best selling point I can do for this. Why coordinate trig is such a big deal. So here's the first thing that I want you to write, and write it off to the side. We're going to have like notes that look like this, where this triangle is off to the side. So try to get this created if you don't have your own notes printed. That's why printing notes sometimes actually is a disservice for you. Hopefully it depends on how you learn, though, what's best for you. Writing stuff down activates your brain a little bit differently. So this is my writing here. Those are printed in notes, so blah, blah, blah. And here's what's going to happen. The very first day today, I'm just going to give you a coordinate. You're going to have to draw that coordinate, and then we're going to do trig off of it. That's really what it is. So how do you draw any coordinate? This always makes me sad. People that get severely behind on this. If you are not able to draw a coordinate this way, you're doomed. All right. The first coordinate listed is the x coordinate. So here's what's going to happen. You're going to be given a coordinate and you're going to draw it. So say this is in quadrant 2 and here's the coordinate given. You're going to draw x. That's the sound of me drawing. Comma, you're going to draw y. So that is the beginning of the start of your triangle, physically drawing the coordinate. Now, it always makes me infinitely sad when students draw y first, then x. If you ever draw a triangle like that, you are doomed. You are doomed, and you'll just accept your F right now. So the reason I put that up or say that right now is not to be mean. It's to actually identify what students do that don't listen to the very first step. It's like, how do I get to Downers Grove from Lockport? Well, take a left on Farrell Road and then go that way. And then your first step is you take a right on Farrell. You're done. You're not getting to Downers Grove. You're already lost. So left X, up Y if we're in quadrant 2. And then for the last side, snap back to the origin. And of course, we know that's the hypotenuse. Why do we know that's the hypotenuse? When I go left and up, I for sure make a right angle in that coordinate movement. Right? So this particular example is a coordinate in quadrant 2. All right? But just keep that in mind here. So if we're in quadrant 2, this is the angle measure in question in standard position, remember, from section 1-1. But this is called the reference angle, the angle that's connected to that one, connected to the origin, all right? But it's the angle in the triangle created by the coordinate move. So this is called a reference angle in there. From this reference angle, that is how we play SOHCAHTOA. All right? Everyone should know that this is the opposite side, the side completely across the reference angle. Everybody should know that this is the hypotenuse. And then, like good old Danny Samuelis back in high school, never understood the word adjacent, but at least I know it's the last side. Adjacent means next to, not the hypotenuse. So that's the adjacent side. Always notice something. If I move coordinately correctly, X first, then Y, and then snap back to the origin, always the opposite side is the Y coordinate. Always. The adjacent side is always the X coordinate in your moves. And then the hypotenuse shall now be called R. And now I'm going to move back to this other stuff for those that didn't print the notes, which is good. You don't need it. You won't get it in college, by the way. I doubt any college professor will print anything for you. You come into class ready with, your own note thing. Actually, R stands for radius. There is something called the unit circle coming up that in a coordinate plane, we put a circle with coordinates on it. All right. And then the unit in circle implies that we have a radius for that circle. So I just want to share that with you. Hypotenuse now is turned into the letter R. It's because of the word radius. By the way, mark this down. I have some chat questions later. Do remember, I'm going to ask you, what is R? R is always positive, first of all. Think of R as the distance you snap back to the origin. It's a distance. Why can X and Y be negative? It's all about coordinates. It's all about locations. What quadrant are you in? So depending on what quadrant you're in, X and Y can take different values, both positive or negative. All right. So this thing right here, sorry, what is that? Paragraph, I guess. I just went through all that. Now it's formally written. Given any coordinate, a right triangle can be created. X, Y, snap back to the origin. The angle in question, theta, creates a reference angle, which is called theta prime, or theta with a little tick mark on it. Where the X coordinate always, I didn't put that word in there, ends up being the adjacent side. The Y coordinate is always the opposite side. And R for the word radius is replaced with, or hypotenuse is replaced with the letter R. Struggling with my words today. Hide this real quick and hide that too. All right, give you a minute to write that down. This is where I'd press pause. It's waiting for the class to take their formal college type notes. I never understood how students struggle with this in the past. Many struggles are not drawing X first and then Y, and then showing that silly little triangle that I drew up there. And maybe not doing section 1-1, just not understanding SOHCAHTOA. Because I am going to actually reference SOHCAHTOA quite a bit and then convert it to in terms of X, Y, and R. So I don't know. Every year I seem to have the same students, some that get this right away and some that it takes a month to figure this out. We'll see what happens with you individually. Really, this is it really shouldn't be that bad. Okay, if you just follow along what we got to do here. Okay, now the next thing is a chart. And I'm kind of reticent about showing you that, little reserved, like kind of, do I really need to show this? And I'm actually going to block some stuff out and try to get related to 1-1 and how it turns into 1-3, what this idea of coordinate trig is all about. Okay, but just kind of blabbering here as we let people write this down. All right. I'm going to get my black highlighter out to delete some stuff. Don't look, don't look, don't look, don't look, don't look, don't look. Okay, so the idea is this. We have this triangle again that apparently in the book, this is the one they like, the one that's in quadrant 2. We could be in any quadrant. Do understand that this is theta, trying to keep with the blues here, or the colors. So theta is this angle measure. But then we do theta prime here to play our little game. Okay, what is the trig of this angle measure? All right, well, we know this is the opposite side. So maybe just redoing what we had up there. We know this is the hypotenuse. Good old Mr. or Danny Samuelis from high school. All right, I know that's opposite. Okay, this is the leftover adjacent side. Now I can play SOHCAHTOA. All right. So of this angle measure, we're going to use this to do our SOHCAHTOA. So here we know that sine of theta is so opposite over hypotenuse. We know unless you didn't do your homework on last week, and that's a big if, right? Some of us, do that stuff. Well, then you continually put yourself behind in a math class that is linear. Someone used that word that this is a linear class. I use the ladder idea. So we got to make sure we understand that before we can understand the next stuff. Blah, 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 blah. We know sine is so, cosecant's a ho. We ain't never going to forget that, now are we? So all cosecant is the flip of sine. All right, and that's all you got to know about that. Cosine is ka, secant is ha. I'll tell you about that x equals 0 thing in a minute. And then cotangent is the flip of tangent. So it's just adjacent over opposite. All right, know those are side lengths as a fraction. And then now it's time to do our conversions. Well, I just said the opposite side is always the y coordinate. The adjacent side is always the x coordinate. If you draw your triangle correctly, and the hypotenuse is turned into the letter R for the word radius. So that implies, I'll leave this alone now and we'll zoom back, that sine is so, but it also is in coordinate sense, sir, which is the acronym that says sine of theta equals y over r instead of o over h. Ka, and this implies that you're really good with SOHCAHTOA as it is. I feel like at Lockport we kind of really cut and cheat you some things here, and then it kind of hurts you in the later classes, but hopefully I'm wrong on that. Ka turns into kixer. Cosine is x over r. And then tangent is tix. I keep trying to get blue. So TOA, tangent is, since O is always the y coordinate and adjacent is always the x coordinate, TIX will be the new acronym. So you will hear me say Sir Kixer Tix for the rest of this semester, not SOCATOA. Sir Kixer Tix instead of SOCATOA. If you're really good with this and you understand how I broke that down slowly, you will have no problem with this. All right, so I guess I didn't read these directions up here. Let x comma y be a point other than the origin on the terminal side of an angle theta. I'll show you what that means when we actually do examples. The distance from the point to the origin is the r value. By the way, I kind of went past this too quick. That's just the Pythagorean theorem. I hope you recognize that. All right. The 6 trig functions are defined as follows. Oh, I'm sorry. Sine is so, cosecant of ho, or y over r now is r over y. Cosine of theta is x over r, so secant's the flip. Tangents tix, cotangents x over y. So hopefully we can get rid of these and memorize Sir Kixer Tix and the flips. But I'll leave those and I'll bring them back. Oop. There we go. Just the translation and really hammer down the point that you take the sine of an angle measure that equals a ratio of sides. All right, so theta is an angle measure, y and r are side measures of the triangle. Knowing that basic relationship there. So when I draw my triangles, they will look like that one I have in quadrant 2. I will still identify opposite, hypotenuse, and adjacent. Remind you that those are x, y, and r, or y, x, and r. I think the way that I said that, but and then we'll play Sir Kixer Tix. So coordinate trig, beginning of your new world. I'm pretty sure you've never seen this before. I doubt you'd have done this in math 2. They probably just did basic geometry trig. SOCATOA, and that's it. Okay, I don't want to circumvent these directions. These are the directions for the first 4 or 5 examples. So it's what we did in that last one. And I'll go over this slowly with you. Sketch an angle in standard position. Remember what standard position means. You start at the positive x-axis, and we're going to go in a positive direction, which is counterclockwise, such that theta has a least positive. No, that's not really important. Yes, least positive measure. We're not going to do more than one rotation. And the given point is on the terminal side of theta. That's what's important. And I'll really make a point of that when we see our first example. Then find the value of the 6 trig functions. Okay, that you can see there. Then we will have to rationalize denominators sometimes. So we're going to sketch the angle. Well, actually, we can't sketch the angle first. We have to draw the coordinate first. So that's kind of out of order. So we have to draw our coordinate x, comma y, snap back to the origin. That's the terminal side. That's where the angle is created. So I'll show you that in a little better way. Okay, so here we go. Ooh, and right away, 7, negative 24. Go look up at your Pythagorean triples real quick, if you wrote those down. Okay, but anyway, that's what I mean about the Pythagorean triples. They're obsessed with using Pythagorean triples, and you'll be able to do your work a little bit faster. So you draw a coordinate plane. You don't sketch the angle because where's the angle at? No, I got to sketch my triangle first. So here's another problem, not knowing how to do coordinates. I have seniors in the past that don't know how to draw 7, negative 24. Well, I'm doing it right now. I'm helping you. But if you can't figure this out in the future, I really cannot help you. All right, so we got to know how to draw triangles or know how to draw coordinates and what quadrant we land in. So 7 comma negative 24 is 7 right, and then down 24. And then how do I draw this? I snap back to the origin. This is the terminal side that this point goes through, or the terminal side goes through that point. This is the angle measure theta. One thing to know about theta is between then 270 and 360, but that's all we're going to know about it. I'm not going to find theta. That's not the point of this question. The point of this question is to understand cirkicks or ticks so we can get the ball moving and do future questions. How do I know that? Because 90, 180, 270. You're past 270, but not quite 360. Knowing that is actually a very important concept. Okay, so knowing that, we start at the positive x-axis and we go in the positive direction there, which is counterclockwise. But to play the game cirkicks or ticks, I'm going to make this theta prime. It's the angle that's attached to the origin, connected with this reference, or this the original angle, not reference. And then I quite simply can play opposites. Oh, wait a minute. I don't have the R value or the hypotenuse. In the chat in 4 seconds, those that looked up those Pythagorean triples, what is the hypotenuse? 4, 3, 2, 1, 0. Come on, let's get people into chat. Nobody looked at their Pythagorean triples? Thank you, Ryan, Amber, Natalie. Maybe I was too quick. You weren't ready. Estelle, nice to see you there. And then, if you didn't know that, well, then this is what you got to do for R. The Pythagorean theorem. We should know that. This is a right triangle, so it's 7 squared plus negative 24 squared. I could not think of what negative 24 squared was last hour. No, this is 49. Let me try and do it. 4 times 4 is 16. I'm going to cheat. 25 minus 14. I can't even do that. Can someone tell me what 24 squared is? My brain is mush. I can't even think of 625 minus 49 right now. It's embarrassing. Is that 576? Nice. I just figured it out. And then that ends up being 625. Okay, but the people that put 25, they looked at our Pythagorean triples. 7, 24, 25. So equals 25. Okay, but now I'm going to do my conversions. The opposite is the y coordinates, y. The adjacent is the x coordinate, x. And this shall be called r from now on instead of the hypotenuse. So I really want you to hammer down sir, kickser, ticks, instead of so, ka, toa. So sine of theta is y over r. Fine. It's opposite over hypotenuse. Either way, it's negative 24 over 25. Cosecant is just the flip of it. And I don't care where you put the negative. It should just be floating out top. Cosine is 7 over 25. So secant is 25 over 7. Once you get the original, the ones that are related to them are very easy. Tangent is y over x flip for cotangent. And that's all she wrote. That's what this is all about. This is what you're going to be doing this. If we get to chapter 8, I'm wondering, last year, you remember COVID happened, like I just said, March. I don't remember I think we eliminated chapter 8. I can't remember. I think we only made it to chapter 7, which is its own unique little chapter to end. But even through chapter 6, you're going to have to know this coordinate trig. You're going to have to know cirkicks or ticks. It comes back all the time in everything that we do. With special triangles, that's going to be chapter 2. Okay, just kind of stalling because you don't have the, you may not have the blank notes in front of you, so you got to write sine, cosine, tangent, cosecant, secant, cotangent, and write all that stuff down. Some note to selves: you never sign air, A-I-R. I get people that write this all the time. sine equals negative 24 over 25. I'm going to mark that wrong so quick. Your head will be spinning. You sine an angle measure, so you need an angle measure noted in that little position right there. And by the way, people that write that do not understand that relationship in the future, that this is a ratio of sides, and I need an angle in there. You sine an angle to get that ratio of sides. So not only is it laziness and not writing that little symbol there, it also leads to major destruction later of your grade. Not because of how I'm going to grade you, it's because you don't understand something well enough. And it does cause problems. I'm going to skip that one, go to this one, because this is more like that last one, but a little different. Oh, nobody got this right when I asked a cryptic little question about this. Made me nervous about Lockport's curriculum and the things that we cut out year after year after year. Or at least they don't cover this as much as they should maybe anymore in Math 2. But let's do the coordinate first of all. So the directions don't really give you the right, how do I start? You do the coordinate first. So I go -1, and I mark it. I go up root 3, just knowing how to move a coordinate, x first, then y second. Not y first, then. If you ever draw a triangle like this, y, x, and then snap back to the origin, you will get an F in this class for sure. You're done. I can't even begin to tell you how bad that is and how that creates such a major, major problem with this. And I don't understand the students that do that, because x is first, y is second. So you move x first, then y. All right, so just make sure you understand that. This book even identifies that that is a major, major problem when you do that. And then snap back to the origin. This is where the terminal side passes through that coordinate, right? So this, yet again, is theta. I hope I did draw that in the other one. That's theta, but I want to use this for what you can do SOHCAHTOA. I know I'm saying Sir Kicks or Ticks. We already know that this is the opposite side. We already should know that this is the adjacent side. So if it does make you comfortable to do that, SOHCAHTOA is fine most of the time. All right. Hey, does anyone know what kind of triangle this is? Or let's ask this first. Does anyone know what R is already? This is actually a special situation. This is chapter 2. You're going to have to know this in chapter 2, not this chapter. But I thought, let's throw it out there right now. I'm going to take a little sip of coffee. The chat's open right now, not doing 4, 3, 2, 1. What is R? If you recognize this as a special triangle, you might already know what R is. Ooh, interesting. Aiden puts 2 question mark. Like, is that 2 from what I remember? Does anyone agree with Aiden or not? If you agree with him, put 2. If not, put nothing. Aiden, I should get, Michael, 2 no question mark. Aiden, I was about to give you, I wish this was, if we were in class and there was no COVID, I'd throw an eraser at you. I mean, not throw an eraser, throw a prize to you, like an eraser for being stepping out above and beyond. It is a 2. Does anyone know what kind of triangle this is then, as far as angle measures? 1, root 3, 2. That was a definite special triangle as far as the angles are concerned. Anyone in the chat? Anyone? What are those angle measures in question? Ooh, Amber's typing. That's fun. Or are you doing something else? Oh, okay. You're probably just turning the volume down so you don't have to hear me anymore. I'm just kidding. I thought you were typing. Nobody remembers this as a 30, 60, 90 right triangle? Raise your hand if you remember that now. 30, 60, 90s, A root 3, 2A. You know, that's a relationship proportionally with all 30, 60, 90s. But again, and I don't think I said this enough, we are not finding this angle measure. The last question that I filled in, we didn't ever find theta. We just found what the cosine, sine, and tangent of that angle measure is. We never found it. The only thing we know about theta is it's between 270 and 360 by drawing it. So we're not finding angle measures right now. We're doing trig on unknown angle measures, just giving their coordinates that they pass through. So, but I actually, in chapter 2, we are going to find out what that angle measure is. All right. If you didn't understand where we got R from, then you'd have to do the Pythagorean theorem. Good discussions. They have to be had to kind of get your head into things that you remember from the past. Then, of course, the square root of 4 is 2. And by the way, r is always positive, or the hypotenuse is always positive in this trig stuff. The only reason x, y, and r, or x and y could be negative is what quadrant you're in. That's the whole point. That's the whole point of coordinate trig. Only what quadrant you land in could x, y, and y be negative, depending on which one you're at. All right. Sine is sir. Y over r is root 3 over 2. Oh, here we go. Remember what it said? Rationalize when possible. When I flip root 3 over 2, I get 2 root 3 over 3. You are going to rationalize so many times that you should not have to write that step eventually. You should not have to write that I have to write or multiply top and bottom by root 3. Cosine is ka or kixer. X over r is what kixer stands for. And then flip it for secant. Tan is toa or tix. Root 3 over negative 1, which is just negative root 3. Oh, no. When I flip this, then I got to rationalize. And this is what I mean about rationalizing. You're going to do this so many times that you should know that that's negative root 3 over 3. You should be able to visualize that I also multiply top and bottom of this one by root 3. All right? I'll leave that up there because you have to write sine. I blabber enough, though, that you can be writing these things down. There is a method to my madness. This is so important. I've denoted a couple things that are the main ideas of this. Knowing angles that are counterclockwise are positive, clockwise are negative. Then also understanding I draw triangles x comma y, then snap back to the origin. And really noting that we could have negative x's or y's just because of quadrants and how we move coordinately. Okay, now I got to jump back up to this one. Now you have no choice. You have to know Sir Kicks or Ticks. You cannot avoid it. You cannot just push it off to the side and say, I'm just going to do SOHCAHTOA because I remember that from, the happier teacher I had 2 years ago, whatever. All right, so here's the problem. We have an angle measure with a terminal side that passes through negative 4 comma 0. Now, this always makes me sad. This is where the stuff hits the fan, so to speak, where I get students putting this all over the place. They either go down or they go left. Now, one of them is right. Correct, I mean. And it's the one that's this one. You go negative 4 to the left and 0 up and down. If you understand reference angles, put it in the chat in 4 seconds. What is the reference angle exact measure? 4, 3, 2. Not reference angle, the actual angle. In standard position. 210. Sorry, Michael. The time kept going after I stopped at 2. He's right. If we're going to be over here and we're starting at this side for an angle in standard position, then the terminal side passing through this, you're at 180 degrees. Now, I did say we're not finding angles today, but darn tootin', this angle is 180 degrees. You can lock it in, all right? And that's actually the next part of our notes, knowing these special situations. All right, this is what I mean. You can't do SOHCAHTOA. There is no triangle. I have no triangle. I have no lift. I don't have an angle measure that makes 3 sides. I just have the side going directly to the left. So you must learn and memorize Sir Kicks or Ticks. You must know that the x coordinate for this terminal side is negative 4. The y is 0. Oh no, what is r? In 4 seconds, what is r? 3, 2, 1, 0. Oh no, this happened last hour. Nobody answered in the chat. R is the distance you snap back to the origin. Put it on the chat when you got it. The distance that you snap back to the origin from the point in question. Everybody should be able to tell me what R is at this point. Why is it only Michael? You're killing me, Smalls, out there. There we go. Now some more people are showing some life here. R is 4, and for some reason it turned blue. Okay, but anyway, so the distance back to the origin is what the r value is. So I don't need no triangle. I just need to remember sine is sir, kickser, ticks, and I must use that now. I can't avoid it. Sine is 0/4. Now, type that in your calculator. Always makes me, it does make me sad a little bit, students, that still, even though I've mentioned it in class, I think, first semester, 0 over a number is 0. You can divide 0 divided by a number. But when I flip it, that's where your calculator, go ahead and type it real quick. That's when you get undefined. So you are going to get some things that say undefined in trig because you can't divide by 0. Cosine is -4/4, which is -1. Make sure I did that. Kind of did that fast. Yep, kickser. And then flipping -1 is still -1. So the reciprocal brothers or sisters, pretty easy. Tangent, hey, take tan of 180. You'll get 0. Check that out as long as you're in degrees. This is exactly no calculator, though. You will not have a calculator on these questions. You'll have to find where the angle measure is, draw the coordinate, and then, pull the correct fractions out. Sir, kicks, or ticks. So sir, kicks, or ticks just replaces SOHCAHTOA. In this case, it's mandatory. There is no SOHCAHTOA. There is no possibility. Uh-oh, Isabella probably went back to her car. Oh, there she is. Okay. All righty then. What we just did is what's called a quadrantal angle. Can you say quadrantal angle? I saw some people's lips move. Good. Here's what quadrantals are. I don't even want to show you this eventually. I don't. In fact, I'm not even going to let you take it down. Okay, because what we just did in that last question really is what deals with quadrantal angles. So here we go. Draw a coordinate plane real quick. You're going to be asked questions right off the bat. What's the sine of 0 degrees? Well, that's a weird question. Sine of 0 degrees. So how do I do that? Well, 0 degrees has an initial side of the positive x-axis and a terminal side of the positive x-axis. You don't go anywhere. You don't lift anywhere. You just stop and stay right on this coordinate plane right here. This is coordinate trig. So if I'm going to be asked this question, I can make up a coordinate. Here I am, happy with math, and I know this is where 0 degrees ends. I just need to write a coordinate there. So what coordinate do I write? Well, any coordinate, as long as it is on this positive x-axis. So I choose to do 1, 0, the smallest coordinate I possibly can use. That's still an integer. By the way, in the chat, x, y, what's r in 4, 3, 2, 1, 0? What does r equal to? Aw, this is making me sad, 6 hour. Okay, boom, there we go. We're getting a lot of people. Colin, I'm glad you wrote that down. It is not -1. R is always positive, no matter where I do any of this. So just make sure you keep that in mind, that R is always positive. Only X or Y could be negative depending on what your move is. Sir implies that sine of 0 is 0/1, which is 0. These have no meaning compared to each other. That's an angle measure. That's a ratio of two sides. Just so happens they both end up being the same number accidentally. And then what if I asked you this question, like, I don't know, let me just do tan. I think this is going to go. No, I don't want to do tan. Let's do sine again, just to see how the differences happen when I move along. Oh, I wanted to still be blue, though. What about sine of 90 degrees? How do you do that without a calculator? Well, first of all, here's 90 degrees. So I have to pick a coordinate right there. In the spirit of what I just did in that first question, what coordinate do you think I'm going to pick here that this terminal side passes through? Go ahead and write that in the chat in 4. 3, 2, 1, 0. Let's see some more. Amber, good. I'm glad you've been answering questions. Ryan, Natalie, good. Colin. This year I had a couple other ones. Obviously, Michael. What's the coordinate I'd probably put there in the spirit of the last one? What, comma, what does this terminal side pass through? That's not a coordinate, Ryan. I need it in coordinate blank, comma, blank. There you go, Colin. 0, comma, 1. Nice, Estelle. We got in there, probably pressing enter. Natalie, both Natalies. Ryan made his change. Absolutely. This is X, this is Y. And I'm not going to bother you with what's R equal to in the chat. You should know R is equal to 1 again, because that's the distance back to the origin. So what's the sine of 90 degrees? Y over R? Now it's 1. Hey, type that in your calculator, and you'll get that verification. You will not have a calculator in your hands when I ask this question when we get back to school for our test. Let's pick a third color. I'm not sure green really sticks out compared to blue. Let's play that game again in the chat. For this terminal side, what do you think the coordinate would be that I choose here? 3, 2, 1. Press enter. Boom. We have a couple. We have a 1, 0, a negative 1, 0. Boom, boom, boom. Good. Now you're getting it, most of you. Okay, so Ryan, I think a couple times missing up on the negatives. Make sure you go left 1, then 0, up or down. And by the way, I do want to cover this. Why 1? Well, you could say negative 7, comma 0. Your R value would just be 7. All right, you're 7 away from the origin. We're just trying to pick easy coordinates that this terminal side passes through in order to do. And then look at pretend I did 0, comma 7. R is equal to 7. 7 over 7 is still 1. So it doesn't matter what coordinate you choose that this terminal side comes through, and it is a choice. It is something that you are going to have to come up with. Well, that's why we do the ones instead of any other numbers. We make our life easy, and we got to make these choices. All right. So I didn't put a trig thing here, but let's stick with sine and show all the differences between all of these. Sine of 180 degrees, oh, we're back to 0 over 1. But if we started doing cosine and tangent, then we get some different, like cosine of 180 is negative 1. And hopefully you see that. All right. And then one more color that probably won't stick out too much, but gray. What's that coordinate that I would choose right there? 3, 2, 1, 0. What's this coordinate that I'd write for 270 degrees? The coordinate that this passes through. Natalie, good. Nasir, Estelle, blah, blah, blah. I missed some people that were before that. It's 0, negative 1. And then I'm not going to put any questions there. We just got to know that that's what we need when we're asked trig of these specific angle measures. So 90 blue, 180 green, 270, and then 360. Come on, you end up where you started. 360 is the same as 360 is the same as 0 degrees. Okay, so this is what I did in the other class. I took this, I yee-hawed it like a cowboy, and brought it really close to this because that's where these answers are coming from. Now, this is what I said. I'm not going to get you a chance to write all this down, but notice when we look at 0 degrees, which is the same as 360 degrees. Notice that chart is exactly the same as far as those output values. Sine of 0 degrees is 0 y over r1. Cosine of 0 degrees is 1 over 1, which is 1. Tangent of 0 degrees is y over x, which is 0 over 1. That's why we're getting those answers, 0, 1, and 1. Oh, no. And then cotangent is 1 over 0, the flip of tangent. That's undefined. Secant is just the flip of 1 over 1. Cosecant, oh no, is the flip of 0 over 1, which is undefined. And that's why you see what you see in this chart of these 4 quadrantals. All right, so I just went through 0 and 360. When I look at the blue, I said I wasn't going to leave this up here. I see people furiously writing it down. Sine is y over r, which is 1 over 1. Cosine now is x over r, which is 0 over 1. There's a change. And then tangent is y over x. Cotangent is the flip of y over x. Secant is the flip of cosine. And cosecant is the flip of sine. That's all I care to go through as far as determining why this chart shows what it shows. You can go ahead and take this. I only have 8 minutes for a little bit more challenging questions, but they're really based off of this concept. You can open up your notes and look at that if you wanted to complete that chart later on your own. I am going to tackle these 3 and then one more example after this. Well, darn tootin', we almost did this one. In the chat, if I'm going to do the tangent of 180, the first thing I have to do is draw 180. Always the initial side. In 4 seconds, what is that coordinate? 4, 3, 2, 1, 0. Who's going to win? Isabella. Nice. And Natalie, you're on fire today. I think you've answered every single question from what I see. Maybe some others have, but when I look up there, I always see that name. Much appreciated. R is always equal to 1. And now we can really just look at tangent. Tangent's y over x. So in sections like this is what I would write. Sir, kicks or ticks up at the top. Just like I told you in regular geometry, write SOHCAHTOA at the top so you choose the right ratio. So this is y over r. This is what I should see as your work, and then see the final answer. Please remember 0 divided by a number is 0. When that's flipped, it's undefined. Right? That could be the big problem there. All right, now you want to get nuts? Let's get nuts. And for purposes of time, probably have to leave the chat here. Negative 450. Okay, so what's the relationship between a negative angle measure and negative side measures? Nothing really. A negative angle measure just implies which way we're going to start off. So remember that from last Friday. Negative 450 means I have to go this direction clockwise. I'm stopping here so that you understand I've already gone negative 360. I've done my first full circle donut in the parking lot. Mathematically, what's left over? Again, for purposes of time, just direct another negative 90. In the chat, what's that coordinate that this passes through? 4, 3, 2, 1, 0. What's that coordinate that I'm going to put right there? Ooh, I still have nobody. You sick of doing the chat? Who wants to win this one? What's that coordinate that terminal side? Oh, Natalie, you just missed. Maybe it's an internet thing. Alexander, good. See you in there. Isabella just snuck in ahead of you. X, Y. Make these mental notes, and also make the mental notes of someone that hasn't answered one dang question this whole time. All right, but it definitely is nice. Okay, so who's cosecant? You got to remember cosecant's related to sine. So if sine is sir, cosecant is r over y. So that's the tie-in there. That's where we use sir, kicks, or ticks. Knowing cosecant's the flip of sine. Oh no, y over r. Oh no, that's actually not bad. Negative 1 over 1, which is negative 1. Okay, so cosecant of an angle measure equals a ratio of sides. Hey, there's another daily. What's going on here? That's hilarious. Make sure you stick around at the end. Okay. Hey, do you remember this, by the way? You have these notes, Emily. Okay. All right. And then 1800. Oh, I'm just going to go ahead and tell you. There's what I had my last hour do. They had to, I said, hey, you know what? Instead of like subtracting 360, divide that by 360 to see how many rotations 1800 represents. And last hour said 5 on the dot. So 1800 is 1, 2, 3, 4, 5 rotations. Now you don't have to draw that. I just wanted you to know how I landed right there. By the way, what's that coordinate? 4, 3, 2, 1. I'm getting sick of doing this in the chat, Mr. Samuelis. Apparently they are, because I haven't seen anyone type what that coordinate is that I'm looking for. Ooh, we still don't have a right answer. Nice. Sorry, Isabella and Natalie. Sorry to say that you got the wrong answer. But what's that coordinate that goes through? Hey, maybe Emily, you can type. Okay, never mind. All right. Because Emily, I'd be sad if you didn't know that. Taught you that. Like, boy, Emily, what was that? 2015, 16? Is that 15, 16? I can't see that. Oh, what is she putting? No, this is a no calculator question. I can't see what she has there. Is that the choosing students function? All right, cosecant. Oh, same thing. Cosecant is R over Y. Oh, no. R over Y is undies. Undefined. Okay, so 1 over 0. All right. Now, I don't have a lot of time for this one, so I'm only going to do one. Here, you don't need the directions. It's going to be evaluate. Oh, no. I got to evaluate this. Okay, so as you're writing this down, I'm going to rewrite one of these. We're going to do the secant of 0 degrees. That's fine. I didn't have to rewrite that one. It's this one. This is just cotangent of 90 degrees, and then you square it. That's just a math trig notation thing. It's actually a mathematician being lazy. That's why we have a lot of symbols in math, because mathematicians are lazy and they want to make things short. And that's really a true story. Okay, so this is all that this means. Here's 0 degrees. Not going to ask you in the chat. We should know that that's 1 comma 0 that passes through with r equals 1. What's secant? Secant is related to cosine, r over x. So secant of 0 is 1 over 1. You write the word secant here, you're telling me you don't know what's going on. You don't know that you take the secant of an angle measure, and the result is a ratio of sides. No word secant anymore. All right. All right. 90 degrees. That's up here. That coordinate, after multiple asks in the chat, is 0, comma 1 for x, comma y. Cotangent, luckily, is x over y. So plus 4 times x over y squared. Luckily, that's 0 over 1, which is 0. If it was 1 over 0 undefined, this whole question would be undefined, because you have an undefined component in this situation. And by the way, 360 degrees is this drawing, because it ends right where you started at the beginning. So I'm going to access those coordinates for that. The cosine of 360 is x over r. So 360 is that same drawing for 0 degrees, same coordinate used. So cosine is x over r, which is 1 over 1. Final answer is 2 times 1 is 2. 4 times 0 squared is still 0. The answer is 3. And Emily, I guarantee you have that exact example in your notes from 4 or 5 years ago. Okay, with all that being said, hasta la bye-bye. It's 10:10. Really, this is an important lesson that really moves forward all the way through May. We're going to be doing circics or ticks or referencing that. All right, have a good day, everybody. Emily, what are you doing? I'm in my final semester at Loyola. Ooh, and what did you do? What are you gonna? Nice. So, like, where, what are you gonna do, like, with that? What, do you have like a job lined up or yet, or no? Is that going to be a part of? Cool. You know, it's funny. We're taping this right now. I got to stop the video. I can get rid of it. So we definitely won't put you in here.